Okay, this is the CRI Demo Math video like I promised. This is going over the first problem on your worksheet, which is the problem in the PowerPoint. So here we have our 44-pound dog who needs dopamine, which is a concentration of 0.2 mg per mil at a rate of 10 micrograms per kg per minute. And we're using a 60 drop per mil drip set. We need to know how many drops per minute we need to administer to receive this appropriate amount of medication. So there are 4 key players when it comes to CRI problems: the patient's weight, the dosage of the drug, concentration of the drug, and the drip set. We know a lot of this information already. So I already put in here 44 pounds, which is 20 kgs for my weight. The dosage of the dopamine is 10 micrograms per kg per minute. The concentration is 0.2 mg per mil. And the drip set is 60 drops per mil. So I notice here when it comes to my concentration that I have mgs and micrograms here. So let's go ahead and get this to a unit that matches the dosage. And so we know that there are 1,000 micrograms in 1 mg. So I'm going to times this by 1,000 to get the new concentration that I want, which is 200 micrograms per mil. So that's my new working concentration. So the first part to solve these problems is a dosage problem. Weight times dose divided by concentration. So let's go ahead and do it. So our 20 kg patient times our dosage of 10 micrograms per kg per minute. 20 times 10 is equal to 200 micrograms per minute. That's my dose. Now I need to divide that by my concentration, which is 200 micrograms per mil. That is going to equal 1 mil per minute. Now, really quick, maybe you're confused why I have mil on top and minutes on bottom. Well, remember, because we are dividing, we are multiplying by the inverse. So I'm just going to rewrite this portion of this problem over here to show you why I got my answer of 1 mil per minute. So 200 micrograms per minute. Oh shoot, let me show you this way, it'll help. 200 micrograms per minute divided by 200 micrograms per mil. So I just rewrote this equation here. Sorry, this is messy. Which is the same thing as saying 200 micrograms per minute, take the inverse, times, so flip these guys over, 1 mil per 200 micrograms. So that's going to leave me with mils on top, minutes on bottom. 1 mil per minute. Okay, so just showing you how I got that answer. So always remember to do that. Okay, so now we're going to take that part of the problem and we're going to do a drip rate, or a fluid drip rate problem. And that's going to sum up or finish up our problem. So 1 mil per minute, and then I insert my drip set, times 60 drops per mil. So my mils cancel. I am left with 60 drops per minute. That's my answer. That's all I asked you for. If I wanted you to give me drops per second, you would divide your answer by 60. Always give me whole drops, but I didn't ask you that. So let's move on to the next one. This problem is not on your worksheet. It is just an example, okay? So here we have a 22-pound dog who needs drug A. Drug A, the concentration is 0.2 mg per mil. The doctor has ordered 10 micrograms per kg per minute. We're going to use a 60 drop per mil fluid administration set. I want you to tell me at what rate, drops per minute and seconds, we're going to deliver this drug at. So we got our weight, dosage, concentration, and drip set. So our patient's weight is 22 pounds, which is the same as 10 kgs. Our dosage is 10 micrograms per kg per minute. Our concentration is 0.2 mgs per mil. I'm just going to go ahead and take care of this right now because I want this to be in micrograms. So I'm going to times by 1,000, and then I'm going to get 200 micrograms per mil for my concentration, and my drip set, 60 drops per mil. Okay, go ahead and do weight times dose, divided by concentration first. So 10 kgs times 10 micrograms per kg per minute, which is going to be equal to 100 micrograms per minute. Divide my dose by my concentration, 200 micrograms per mil. And so we're going to get 0.5 mils per minute. So then we take that part, 0.5 mils per minute, insert my drip set, 60 drops per mil. Mils cancel. 60 drops times 0.5, that's going to equal to 30 drops per minute. That's my one answer. Let's get drops per second. So I could simply just take 30 and divide by 60 because there are 60 seconds in 1 minute, but I will also just write this out the long way. So 30 drops per 1 minute times, well, in 1 minute there are 60 seconds, so 30 divided by 60 is equal to 0.5. So I need to get a whole number. We cannot deliver partial drops. So times 10 is going to give you 5 drops per 10